Have you ever stumbled across a bridge that wasn't built by people? I mean, a bridge made entirely of sand. Today, we're diving into one of nature's coolest tricks, a tombolo. It's where the ocean, of all things, plays engineer and builds a path of sand connecting an island to the mainland. So how on earth does that happen? Let's get into it.
I know, it sounds kind of crazy, right? The ocean is all about powerful, crashing waves, chaos. So how can that build something as neat and tidy as a bridge you can literally walk on? Well, it turns out that behind all that wild energy, there's a system at work, a really organized and, believe it or not, very predictable process.
All right, so where does the ocean get all the building materials for this huge project? The secret is this incredible, non-stop process that works just like a giant conveyor belt, shuffling sand down the coastline day in and day out.
And this conveyor belt has a name. It's called longshore drift. This is the absolute key to the whole thing. And it all starts with the wind. See, the wind usually blows from one main direction, right? This pushes the waves so they don't hit the beach straight on, but at an angle. And that angle is everything.
Okay, so here's how that movement actually works. It's like a little two-step dance happening with every single wave. First, you get the swash. That's the wave pushing sand up the beach at that angle we talked about. But then gravity kicks in. It doesn't care about angles. It just pulls the water and sand straight back down. That's the backwash. So you see what's happening? Up at an angle, straight back down. Up at an angle, straight back down, over and over again. This zigzag motion is what creates that conveyor belt effect. Each wave nudges the sand just a little bit further down the coastline. It's slow, but it's relentless. All right, so we've got our conveyor belt of sand chugging along the coast. But what happens when that nice, straight coastline suddenly takes a sharp turn? Well, that's where things get really interesting. This is when the ocean stops just moving sand and actually starts building something with it. Now, for this to happen, the conditions have to be just right. It's kind of like a recipe. First, you need that sharp turn in the coastline we mentioned. That change creates a pocket of calmer, more sheltered water. And just as important, you can't have a powerful river mouth nearby that would just flush all that sand out to sea. You need a calm spot for the sand to settle. So picture this, that conveyor belt of sand comes around the corner and suddenly hits that calm, sheltered water. It's like the water just runs out of breath. It loses its energy and can't carry all that sand anymore, so it just drops it. And over a long, long time, all that dropped sand starts to pile up. Eventually, it forms this long, narrow finger of sand stretching out from the land. And that, my friends, is called a spit. Okay, so we've got our spit. It's getting longer and longer with every tide. But it's just a finger of sand pointing out to sea. It's not a bridge, not yet. To become a bridge, it needs somewhere to go. And that conveyor belt just keeps on running. It doesn't stop. It keeps piling more and more sand onto the end of the spit. So the spit just keeps growing, stretching further and further out into the open water, away from the mainland. Until, bam, it reaches a nearby island. It makes contact. And just like that, you have a bridge. A solid connection of sand has formed where just a little while ago, there was nothing but water. And that amazing natural bridge, that has a special name. It's called a tombolo. It's basically a spit that didn't just stop in the water. It kept going until it connected an island back to the mainland. I mean, if you've ever seen pictures of St. Michael's Mount in the UK, that beautiful causeway you can walk across, that's a classic tombolo. The ocean literally built its own bridge. So there we go, a land bridge built by the sea, solid as a rock. Well, maybe not, because there's one last really cool twist to this whole story. I mean, after all that time, literally thousands of years of sand piling up, you'd think this thing would be pretty permanent, right? But what if I told you that this bridge sometimes just disappears? And here it is, the final piece of the puzzle. The very same ocean that spent all that time building the tombolo can take it away. Well, for a little while anyway. At high tide, the water level can rise high enough to completely submerge the bridge of sand. It just vanishes under the waves, only to magically reappear a few hours later when the tide goes back out. It really changes how you look at the coast, doesn't it? What looks so solid and permanent is actually in constant motion, always being built up and worn down. It's a living landscape. So, the next time you're standing on a beach, take a closer look. You have to wonder, what other amazing temporary secrets is the ocean hiding or creating right under our noses?